classical physics, laws describe the motion of planets in the solar system. They were derived by the German astronomer Johannes Kepler, whose analysis of the observations of the 16th century Danish astronomer Tycho Brahe enabled him to announce his first two laws in the year 1609, and a third law nearly a decade later in 1618. Kepler himself never numbered these laws or especially distinguished them from his other discoveries. Kepler's three laws of planetary motion can be stated as follows.
Planetary motion is the law of harmony.
Kepler's second law, a radius vector joining any planet to the Sun sweeps out equal areas in equal lengths of time. And the third law of Kepler's of planetary motion is law of equal area. The squares of the sidereal periods of the planets are directly proportional to the cubes of their mean distances from the Sun. This includes the perihelion and aphelion.
Law of planetary motion. The law of ellipses. The planets orbit around the Sun.
All planets move about the Sun in elliptical orbits, having the Sun as one of the focus.
The history of Johannes Kepler published his first two law about planetary motion in 1609. Having found them by analyzing the astronomical observation of Tycho Brahe, Kepler's third law was published in 1619. Kepler had believed in the Copernican model of the solar system, which called for circular orbits but could not reconcile Brahe's highly precise observation with the circular fit to Mars orbit. Mars coincidentally having the highest eccentricity of all planets except Mercury. His first law reflected this discovery.
Kepler in 1621 and Godefroy Wendelin in 1643 noted that Kepler's third law applies to the four brightest moons of Jupiter. The second law in the area law form was contested by Nicholas Mercator in a book from 1664, but by 1670, his philosophical transactions were in his favor. As the century proceeded, it became more widely accepted. The reception in Germany changed noticeably between 1688, the year in which Newton's Principia was published and was taken to be basically Copernican, and 1690, by which time work of Gottfried Leibniz on Kepler have been published. Newton is credited with understanding that the second law is not special to the inverse square law of gravitation, being a consequence just of the radial nature of the law, while the other laws do depend on the inverse square form of the attractions.